Greetings, mathematicians. In this video, we're going to continue simplifying rational expressions or rational fractions. However, this time we're going to be taking it to the next level by looking at fractions that are not already factored. So just remember that when we factor, we always look for these three things, and in this order. First, we look to see if we have a GCF. And we're basically going to be doing this twice. We're going to look at the numerator and the denominator as like two mini problems. So look for a GCF in both. Then look to see if we can do difference of squares or factoring by grouping, depending on whether it is a binomial or a trinomial. And then after that, once the numerator and the denominator are both factored, look to see if there are any common factors that divide out to 1. So let's start with this example 4. And if we look at just the numerator first, we have x squared minus 4. There are no common factors, no GCF, but x squared minus 4 is a difference of squares. That factors into x plus 2, x minus 2. Now if we look at the denominator, x squared minus x minus 2, that also does not have a GCF, but it is a trinomial, which means we're going to be using our grouping method. So remember, kind of off to the side here, I'm going to write my final answer underneath in the denominator, underneath my x plus 2, x minus 2, but sort of off to the side, I'm going to do the work here. Remember that this is the one where we look and we compare this to ax squared plus bx plus c, and we start by finding what numbers multiply to AC, so 1 times negative 2, which is negative 2, and which of those values then add up to B. So we're looking for numbers that multiply to negative 2 but add up to negative 1. Now, we don't have a ton of choices here. To multiply to 2, we only have 1 and 2. And if they need to multiply to negative 2, it's either negative 1 and positive 2 or positive 1 and negative 2. Those are our only options. And the ones that add up to negative 1 would be the second set. 1 plus negative 2 is negative 1. So we're going to be rewriting our trinomial as, instead of the negative 1x in the middle, we're going to write plus 1x plus negative 2x. We're going to leave the first term and the last term the same. And then remember, the reason we call this grouping method is that we group the first two terms and the second two terms together. And then we do two mini GCF problems. So we first look at the first set of binomials, x squared plus 1x, that has a GCF of x. And then we look at the second binomial, negative 2x minus 2. That has a GCF of negative 2. Remember that if you've done this correctly at this step, the part in the parentheses after you've taken out the GCFs, that should be the same. And then our next step will be to factor out that common binomial. Factor out the x plus 1. And then that leaves us with an x and a minus 2 in the other parenthesis. So going back up to our original problem, that means that x squared minus x minus 2 factors into x plus 1 times x minus 2. And now that we're looking for common factors in the numerator and the denominator that divide out to 1, x minus 2 divided by x minus 2 is 1. So our final answer here, x plus 2 times 1 in the numerator is x plus 2, and in the denominator, x plus 1 times 1 is x plus 1. Now moving on to example 5. In the numerator, we have got this polynomial with 4 terms. It's sort of like over in example 4, where we split up our trinomial into 4 terms, but that part's already been done for us. So we kind of have a little less work here. We're going to group the first 2 terms and group the second 2 terms and do our mini GCFs right here. So in the first 2 terms, x squared plus 3x, that has a GCF of x. And then when I factor that out, that leaves me with an x plus 3. And then in my second set of binomials, my 5x plus 15, that has a GCF of 5. And when I factor that out, that also leaves me with an x plus 3. So I've got a common binomial of x plus 3 that I can factor out, and then that leaves me with an x and a plus 5 in the second set of parentheses. So my work, I just kind of showed my work underneath there, that leaves me with an x plus 3 times x plus 5 in my numerator. Now for my denominator, x squared minus x minus 12, that also does not have a GCF, but it is a trinomial. So if I'm looking at my a times c, that's 1 times negative 12, which is negative 12. My b is a negative 1. So I'm trying to think of two numbers that multiply to negative 12, but add up to negative 1. That would be negative 4 and positive 3. Those multiply to negative 12, but add up to negative 1. So I'm going to rewrite my trinomial. I'm going to keep the first term the same. I'm going to keep my last term the same. But for my middle term, instead of writing minus 1x, I'm going to write minus 4x and then plus 3x. And then keep my last term the same. So this is equivalent. I'm just rewriting the middle term as minus 4x plus 3x rather than minus 1x. Now the reason, again, this is called grouping method is because I group the first two terms into a binomial, group the second two terms into a binomial. In the first two terms, that has a GCF of x. Factor that out. That leaves me with x squared, or leaves me with x minus 4. For my second two terms, that has a GCF of 3. Factor that out. That leaves me with an x minus 4. Remember that if you've done this part correct, you should have a common binomial. In this case, that common binomial is x minus 4. Once I factor that out, that leaves me with an x and a plus 3 for my second binomial. So that's my work for the denominator. And I'm going to rewrite my denominator. It's now factoring out to x minus 4 times x plus 3. And I'm looking for common factors. I have an x plus 3 in both my numerator and the denominator that divide out to 1. X plus 3 divided by x plus 3 is 1. So then my final answer, 1 times the quantity x plus 5 is x plus 5 in my numerator. And in my denominator, x minus 4, that quantity times 1 is x minus 4. So my final answer is x plus 5 over x minus 4. All right, now to wrap up here, I'm going to have you pause the video and try these 4 problems on your own, and then come back to check your work. All right, and now that you've had a chance to try these, here are some solutions for you to compare your work with. That is it for this video, and we'll see you next time. Bye for now.